By profession, I'm a chartered mechanical engineer, and I started my career working with the UK government on building services design, addressing many of the issues that we've talked about today: clash detection, design coordination, training, handover to operations, some of the big issues that still plague us today, 20, 30 years on. BIM for me is really about the process of creating and managing asset information through the life cycle. And the process part there is really important. So it's not about a tool, it's about a process of creating and managing content. And somebody in the UK's BIM task force a couple of years back reminded me, he said, look, an Excel spreadsheet can be a BIM. So don't get hung up on it has to be the big 3D glamorous fly around. It's all about the data. So I'll try and explain what I mean by that and how that data works through the life cycle with reference to some of these topics. Now, I am from Bentley, but I don't propose to show you Bentley demonstrations as we go through the presentation. But I will touch on some Bentley applications where I think there's a direct application to some of the things that we've been talking about today. So really, for me, there are two main drivers in the industry, wherever I look, in the UK, in Europe, the US, and Australasia, and Southeast Asia. It's really cash and carbon. Now, cash because increasingly there's less and less cash around. And I'm sure we've all worked on projects recently where the client's saying, look, we need to review the project because we're not sure what the market's doing. Or we need to reappraise this government scheme because the government budget's been cut. And carbon because there's too much of it. We're creating too much carbon dioxide. That's coming from energy production. However we produce energy, it's creating carbon. And when you take the politics out of it, reducing carbon is just about good business sense. It's making ourselves more energy efficient, more productive. You know, somebody had a slide this morning talking about energy production, and this is really one of the ways that we can start to drive productivity in the industry. Just as a reminder, here's an advert from the 70s from Humble Oil, who are boasting that they can melt 7 million tons of glacier per day with the energy they produce. Okay, so that was just about 30 years ago. So it really brings home the fact that energy use is really important. So whether it's carbon or not, its energy is critical. And BIM and life cycle management are some of the ways that we can start to address this. So just thinking back to the topic that was on the first slide about linking BIM to all these different things, I'm going to look at it in three ways. So the first is information modeling. And that's the thing that we're mostly familiar with. It's about creating that thing, the object, the building, the pumps, the fans, the skirting boards, the tables, the chairs. It's the BIM thing that mostly we focus on. I'll then look at integrated projects, because the forgotten half of BIM is about managing all the information. So BIM is about creating and managing content, but as an industry, we tend to forget the whole management part. Now, it's good to see people like Singapore doing some good work there in terms of automating that process of sharing information, sharing content for different uses. And we need to go a lot further as an industry in that. And that then means we can deliver intelligent infrastructure for clients. And that's why we're here. That's what we're doing. We're not doing BIM or building services or building design for the sake of it. We're doing all this to deliver an asset to a client. And that can be a piece of rail infrastructure, road, airports, buildings, a whole range of different things. And what that gives us is two main things in my mind. One is that underpins everything is return on investment. You know, we're doing some of this smarter stuff, not for the sake of it. We're doing it because it makes good business sense. And we also gives us a great return on talent in the industry. So we talked about training and some of the great things that Singapore's doing in terms of driving that need for improvement right down through the academic institutions. So when you start doing some of this smarter stuff, it really sort of upskills the industry and it gets people having a buzz around what they're doing. AECOsim is another acronym in addition to BIM. And I've put that in because on some of the major schemes that are happening in Europe now, people have stopped talking about BIM. And what they're saying is it's now Asset Lifecycle Information Management. Because when people talk about BIM, they tend to think about it's the architectural bit, it's the glamorous above-ground thing you can fly around and walk through and schedule from and do 4D, which is all part of the process. But really it detracts from the integrated projects that we need to work on and deliver. And it also detracts from delivering intelligent infrastructure for clients. Now, I'm sure you've found that many of the clients you work with will probably say, look, we don't care how you deliver this building. As long as my aircraft hangar or my hotel is delivered by a certain date, time, cost, and quality. That's it. I then want good quality handover information because, as for example, a hotel owner, I know that's where my costs are. It's in operation. It's not in really delivering the project. So looking at the first one, the information modeling. On the left, we've got a whole series of coloured shapes and blobs and squares and so on. In fact, an architect said to me recently his work, when they're doing BIM, is being reduced to that of a blobmeister. He said, we're creating these fancy shapes and complex curves, and the actual design is being taken on by specialists, specialist manufacturers, contractors are doing design. He said, and we're doing the blobs. And that's an important part. We need to do that. But we also need to then use those blobs, those things, for doing energy simulation, analysis, building performance, crowd control. All these different things that we need to use the virtual environment for can come from that content. So it's important we get that content right at the start. Trusted deliverables. Somebody mentioned this morning about having good quality construction documentation. And let's not lose sight of the fact that many of you here still are using 2D drawings, because that's how we've worked for a number of years, for a long, long while, and it works. Now, we know where the risk is in doing that, but there are established processes for actually working with 2D content. So in the BIM environment, we still need to make sure we don't lose sight of the fact we're delivering construction documentation to deliver an asset. And it's not just Bentley saying this. Engineering News Record are saying it's all about the data. So repurposing data and information. And creating facilities models for operations and maintenance. Green BIM. Again, green BIM gets bandied around as a term, and it means different things to different people. But we all know that green BIM is on the rise. More people are challenging you, I'm sure, and saying, look, is my building green? Is it sustainable? How much energy will it use? What's the embedded carbon? So all these things can be addressed where we're doing BIM properly in a project environment. From Bentley's perspective, we have our own BIM tools. So the latest version to come out a few months ago was AECOsim Building Designer. So AECOsim is a fully featured, fully integrated, multidisciplinary BIM tool. And it does a load of great things. It creates the nice pictures, it creates the content, you can create construction models, you can put content from suppliers' databases into a model, you can do all the smart stuff with it. Again, the key thing is really about the data. It's making sure you've got data groups set up, classification systems set up to create, capture, and manage that data through the life cycle. And one of the features I want to pull out with AECOsim is an innovation from Bentley called hypermodeling, which some of you may have seen. And this is really a way of addressing the disconnect between 3D models and 2D drawings. So what we have here is it's a 3D model, but you can see we overlay the 2D content. So where we want to reference in maybe some details or dimensions, specifications, photos and videos into the model, we can do that. And the key thing there is you don't have to put everything in the model. There's a temptation sometimes to try and load all the data in and put a huge amount of detail into models. But really you don't need to do that. It's not an efficient way of working. And also it gives you a very easy way to reference between the two, between 2D and 3D, and capture that content. When we're creating these blobs, these shapes, we can then do things like solar shading, solar analysis. So when the architects and planners are working out where this building sits on a site, we can start to do some of this clever stuff, looking at the site orientation, look at the building form, look at where it sits on the site in relation to other buildings and trees and rocks and cliffs and so on. So we can start to do some smarter stuff there. And the other important aspect when we're creating all this content is about integrating it and sharing it. Because it's no good if I create an architectural model or a steelwork model and I can't share it with a building services colleague. It needs to be in a format that it can be shared easily and openly, because with BIM, the more we can reuse something we've created, the more value we get from it, and the better the return on investment. And that doesn't mean we have to all then standardize on, in this case, AECOsim, or on some other parametric modeling tool or a detailing tool. The key thing is to look at open standards. So Bentley works hard across the globe to try and support different initiatives that are looking to drive open standards. So we don't get hung up on which version of which application are you using and trying to get everybody to use the same thing. Because in the real world, that's never going to happen. So we have the integrated dashboard from Bentley, which means if you're working in different BIM applications and you want to share information about steelwork detailing between different software packages, you can do that. There's always a solution. And increasingly, it's not about the technology. You know, I've heard people saying, look, there's an app for anything. Whatever you want to do in construction or design, there's normally an app for it that sits on a desktop or an iPad or an iPhone. It's not about the technology. It's really about the process that sits behind it, and it's how we can use it smartly. So looking at the energy side of things now and simulation and performance, you know, every building is a forecast, it's a prediction. We can never know exactly what's going to happen. And it's been said that every forecast is always wrong because we never get it exactly right. From the Bentley suite, we have an application called AECOsim Energy Simulator. Now what this is, it's a ground-up application based on the Energy Plus simulator engine from the US, which means you can either import models from somebody else, from a different application, using, for example, GBXML, or a DWG import, or a DXF import. You know, a number of ways you can bring other content into this analysis package. So if you're doing the energy design, you don't have to think about which packages were used to create the building. You can just bring that in a suitable file format to do the analysis. And the important thing is it just has codes built in. So you don't have to think again about which code am I using, which standard am I using, which page is it on. And I think back to my time as a graduate engineer with a whole stack of CIBSE guides and ASHRAE guides and tables and things to have to work through to design all this stuff. It just takes the grunt out of it. So what it means is that engineers and designers can now spend more time doing the clever stuff rather than doing the grunt of having to look through manually tables and schedules and spreadsheets. So when it comes to looking at those different options, one of the good things about AECOsim Energy Simulator is it has a number of templates for systems built in. So these blue blobs here, you can configure these. These are air handling units and fans, control units, dampers, and so on. And you can just click and drag for a number of preset systems, and you can move those around to suit the configuration you want in your building. So a packaged VAV system, a central VAV system, and a heat pump system. And that's handy in its own right because it helps you to do the design. But then the clever thing is when you start to do that energy analysis and do some comparisons. And because it's a quicker and more efficient process, and we're taking in design content from other people, regardless of which package they've used for modeling, it means we can spend more time doing this clever stuff. Because when it comes to the client and the guy that's paying the bills for energy, you know, this is what excites him. He doesn't care how the plant room's laid out or where the clashes were. What really gets him excited is all this stuff about energy use. And the final part is Compliance Manager. Now what this is, at the moment it works in the States for lead compliance. So it will work soon for Green Star over here in Australia and BREEAM in the UK. And it's an online system for checking compliance. So in this case it will give you a lead assessment. You know, is it gold, is it platinum, is it something else? It shows you where the items are, the big ticket items that you can maybe influence from design. And it takes away that grunt of having to do that manually. So it's along the sort of theme that Singapore's doing with plan submissions. Okay, so you can submit your building up into the cloud and it will come back with an assessment and it will give you some nice metrics about performance, what can be improved, what's over-designed, what's over-performing. And you end up with a whole series of metrics and KPIs that you can look at and that will be unique to your building. So every building is different. For some, it will be about the form and the function. For some, it will be about energy use, people movements, traffic flow, any number of metrics. But the key thing is we're creating this information, this intelligent information, that helps us to do this kind of analysis more quickly and more efficiently. So then when you come to look at how you integrate all this information, that's the other really important part. It's no good having all this intelligent content if you can't share it and reuse it. And I've put the London 2012 logo up there because Bentley was a technology partner when the project kicked off. So we worked with the delivery authority and LOCOG because they said, look, we want to do some of this smart stuff. We've got, at the time, it was just under 6 years to implement this Olympic Park, and we know we need to do some intelligent modeling and some intelligent integrated project delivery processes. And they put a lot of effort into scoping this whole system and environment before they started. And what we had was the different supply chain partners were using their own software and their own tools because the times were very short. The client couldn't say, right, everybody has to use product A for modeling or for CAD. They said, right, use whatever you want. It doesn't matter. Providing when you deliver that to the center, you deliver that to us as a client, it's in certain formats, again, neutral data formats, with data in a way that we can use. And they were using Bentley's ProjectWise collaboration system to do that. But individual firms are using their own collaboration tools internally and then publishing to the client's collaboration system using ProjectWise. So it's really important we can share all this information. And there's a quote here from a BIM journal saying that in real life, we are never going to get to the point where we have one application or even just a few applications across the industry. It's always got to be about using the best tool for the job for the right project stage. And the interesting thing for me on this journal is at the top it talks about GIS, because that's one of the forgotten things about BIM. Again, people think about the building or a bit of infrastructure, but the GIS often gets forgotten. And if you're a major asset owner, if you're a rail operator, if you own a campus somewhere, a university campus, an Olympic park, then the GIS is really important. That's a key part of your ongoing operations. So GIS really is just it's another data source. So you have to think carefully about how you integrate that. And there are some great examples of projects globally where this is being done, where they just think of GIS and building information and road and rail. It's all just part of the virtual infrastructure of that digital environment with data. And it's a bit like the old battle, if some of you can remember it, back in the 70s and 80s, between VHS and Betamax. You know, it was a really two-horse race. You had to decide, are we going to go for VHS or Betamax? Which is the right horse to back? And there are still some in the industry who will say to you today, look, you have to decide which application you go for. Do you stick with vendor A or vendor B? Which is your parametric modeling tool, and which version? Is it this one or this one? But really, we've moved on from there. You know, it's not like that anymore. You never hear people arguing about cameras in terms of giving you the JPEG image. You know, providing you get that JPEG image of the photo that you can use on a website or Facebook, or you can blow up to a poster, no one gets hung up anymore on whether it's a Sony or a Panasonic or some other manufacturer. It's not about the device, it's about the content. So really, it's us as an industry that win there, because we get to spend less time fighting about applications and which versions. And contractors get naturally excited by this because they see the highest return on investment. And for me, the biggest, I suppose, example of that was when I worked with a big contractor in the UK. Before people were doing BIM, and BIM was on every page of technical journals like it is now, we would take a set of consultants' design drawings in the mechanical and electrical division. We'd take a set of consultants' drawings, the PDFs typically, and we would create a 3D model of the building and all the services. And we spent 3 to 4% of our contract value doing that. Now, when you think about that, that's 3 to 4%. So a $100 million project, we'd spend up to $4 million just taking someone's 2D design and creating it in 3D. And it was purely for clash detection and coordination. We never passed it on to anybody else. It was kept purely internal. And we did that because we knew, and as we've seen examples here today, it saves many times that in terms of savings and less time on site and more efficient processes. So we've been doing it for a long while as an industry, and it's now starting to get some credence and some credibility with people now doing case studies and saying we can save X percent here and Y percent there if we do this, that, or the other. So there's some big gains to be had. And let's not forget, this is what we're looking at. It's the digital infrastructure. It's not just about the building or the plant room or the service void. No, it's everything. It's offshore, it's onshore, it's ports, it's harbours, it's road, rail, power plants, mines. It's everything. It's all part of that asset environment that we're dealing with. So when you start to look at it in that context, federation of data and content is really important. Because again, you need to let each individual party to that project create their own content using their own applications in their own way. And there's an example up on the top left of the data sets for a hydraulic power system in China. So there's a whole range of different content that's created. You know, environmental, some of that is purely 2D. It's reports, it's specifications, it's data sheets. Some of it is the more familiar buildings we've got here, building information, architecture, structure, mechanical. But the key thing is you let people use the tool that suits them in their own way. And it's a very efficient way of working, because you can break down those models to suit the building, suit the zones, suit the deliverables. And it's very efficient. And just to highlight that, it's really, for me, it's the difference between, for example, SAP as a database system that some of you may be familiar with, and Google. Now, SAP is a massive database of stuff. So some businesses use it to stick all their content, all their knowledge into one big box on one server, and then use some tools to query that. And the Google approach just says, oh, it's too hard. We're never going to do that. You can't stick the globe in a box. It's just not big enough. So what they do is index everything. And when you raise a query, it says within 0.2 seconds, we'll come back with a whole set of answers for you. So 0.2 seconds to go off globally and source some information. That can be in PDF, it can be models, it can be anything. So that's really the world we're moving to, is about that federation of data. Now, to do that, interoperability becomes really important. Going back to what I was saying about open standards, it's no longer the case of trying to get everybody on a project using product A or vendor B or system C. There's a whole range of these different things out there. And these are just some of the open standards that we use in the industry. I mentioned GBXML for environmental and energy analysis, OGC for geospatial information, there's SAP, there's Microsoft Office, there's ISO standards. There's a whole range of these things out there. I'll just make a quick plug at the moment for the Open BIM Alliance of Australia that's just been founded. There's a list of the 7 or 8 founding firms there. And it's all about having principles for open standards. So it's lobbying government and firms and projects and individuals to say, look, let's not push proprietary systems. Let's keep it as open as we can. So I'd encourage you to look at that and maybe become involved. And one of the ways that Bentley addresses the need for interoperability on projects is through the Bentley I model. Now, the I model is not just another file format that we have to work with. It's a container for information. And it's a bit like creating a PDF for a Word document. We can take a big parametric model that an architect or an engineer has created, we can publish it as an I model, and it becomes a fraction of the size. But all the data, all the intelligence, the geometry, all comes across into this small container of information. And once it's in that container, it can then go off into Excel or Crystal Reports or Access, or it can go into another BIM package or some analysis tool. So it's a very flexible way of taking information from a range of different vendor-specific applications, putting it into a neutral format, and then repurposing it. So it's Bentley's way of saying, look, don't make interoperability your problem. Let that be our problem as the industry. We can help you do that. That shouldn't be your job. Your job is design and construction and operation and all the clever stuff that goes around delivering assets for clients. So you don't need to get hung up on the software. A big issue with contractors is using content. We've seen some information about content this morning. And assume it was saying Bentley sits on the steering group for BIM MEPOS. Coming soon is what we call the Bentley Content Store. And what we have here is a whole series of content from different manufacturers. So they publish up content to this web-based service. So if you're working in a Bentley application or another application, you can go onto the store from within that application and pull down the content that you need. So this is not a live web, this is just some screenshots from it with pumps. It's just a quick way of searching for information. So you've got, what is it you've got, what's the description, you get some specification. There are some documents that go with that. 2D, 3D, energy analysis, embedded carbon, environmental assessment, any number of things. Whatever that valve manufacturer has got in terms of data and information is stored up on here. So if it's a BIM MEPOS compliant object, again, you don't have to think about, is it compliant? If it's on there as part of the BIM MEPOS schema, you can use it. Related objects, similar objects. The people are used to going on to things like Amazon. It's a similar sort of principle. Users who bought this pump also bought, a gate valve, and it's that kind of approach. People are just used to using this. The specification content, the data, all just sits there. So the users don't have to think about that stuff behind the scenes. So integration for contractors. They've got their design team on the left creating the intelligent models, the information models. And at a certain point, that gets passed across to the contractor. And the contractor's normally the one left holding all this different stuff. And as an industry, again, we focus increasingly on the 3D model. But let's not forget, we've got the guy at the bottom who's digging a trench or filling in a hole. He may not want a model. He might want this stuff. He still wants the paper or a faxed A4 diagram or note showing what he has to do. So it's about the right content in the right format for the right job. It's never a case of one size fits all. So a number of BIM projects that we're all working on, there's 2D content in paper form, it's PDF, it's electronic paper, and it's 3D models. So it's a whole range of media, but it's really about understanding the best media for the job. And mobile applications are becoming even more important. There's a whole range of devices around now. I think everyone's got one in the room today. iPads, iPhones, Galaxy tabs, Windows tablets are coming out soon. There's a whole range of things. And the trick really is then looking at how we can get value from that. As contractors, as designers, as suppliers, how do we actually leverage that and get value? Rather than just having them for the sake of them and thinking, wow, this is really cool, look at my iPad. How do we get value? So Bentley has its own iPad applications. Bentley Navigator for the iPad for reviewing and commenting on drawings and models. And ProjectWise. So the ProjectWise system that is used at an enterprise level on projects like London 2012 Olympics, you can take out a version of that on the iPad that links you back into your main data source. So you're not copying information onto your iPad and having two uncontrolled copies. The version on the iPad actually checks out and downloads a copy for you to use on site. And while you're doing that, nobody else can interfere with it or use it. So it's all about managing that information flow. And when we think about field-based applications, what we're doing is we historically or typically we take out a package of information from a site. We go out onto site, we record it, we take photos, we make some notes, and then we go back to the office and we update our system. When you're working with field-based apps on mobile devices, you cut out a whole chunk of that. It's much more efficient. You don't have to go back to the office to upload. You're out on site, you take a photograph, and you press the button, you save it back into your project store. So it's a very efficient way of working. And there's a whole bunch of field-based tasks out there. And again, if you go onto the iTunes store or you go onto some construction websites, there are literally hundreds of field-based application apps that you can download and use. And they'll become more and more. But the real magic happens on the server. To get those integrated projects, you really have to have things going on in the server in an intelligent way so you can push it out to the people on site or in the design office so you know they're using the right information at the right time. So the third part of the jigsaw is the intelligent infrastructure. So this is what it's all about. It's delivering these assets through integrated teams to the client at the end of the day who's actually managing all this content. And this is the guy that ends up with it all. This is the guy that pays the bills. So when you've done your energy analysis, you've thought, yeah, that system's great, that's okay. This is the guy that actually pays dollars every month to sustain that facility. He's also the guy that ends up being given a whole load of FM models and data, where project teams say, look at this great thing that we've created. We're going to give that to you for FM. And I've spoken to some FM projects recently in Australia, some FM providers in buildings and owners, and they say it's all great, but we can't use it, we don't need it, or it gets out of date. No one updates it, no one keeps it current. So again, let's not forget that we're looking at all this infrastructure. It's not just about a building or a stadium or a piece of rail. There's a whole bunch of different software out there that we deliver up to clients and expect them to use. And also, let's not forget that the delivery of the asset is just one small part of the infrastructure lifecycle. You've got this area in the bottom left in green, which is about delivering the project. So that's the building, it's the stadium, it's the rail. But really, all the clever stuff, all the smart stuff goes on downstream. It's when you get a series of smaller projects. For churn, you'd subdivide a small office into two smaller offices, or you extend a ward in a hospital, or you do an extension to a building. All these things, you need to get good as-built information, you need to access the data, you want the design history, and it's about safety, compliance, audit trails. So as an industry, again, we tend to think of the building, this bottom left bit in green, as being the thing. But really for clients and the owners, it's all the rest of it. Just to give you an example of what intelligent infrastructure means in practice, there's an example of a water provider in the UK, United Utilities. And like most providers, they have water networks that leak. Okay, no system is ever completely leak-free. But what they've done is they've got some graphs of water usage and leakage and flow rates. And the blue line is design. So that says with no leaks, this is what we should have in terms of flow rates. The red line is what they actually get because they have leaks. It's not a perfect system. It's an aging system. Some parts are new, some are old. And they've written some algorithms using Bentley software that are based on Darwinian evolutionary algorithms that actually look at the system, they look at flow rates, they look at where the leakage occurs. Every time someone phones up and Mrs. Smith says, look, the water mains burst in my street, they log that in the system. And the system goes through a process of learning where the system leaks and where it's more likely to leak. So if you find you've suddenly got a loss of pressure somewhere or there's a leakage, you're more able to find where it is. So it saves time and effort in tracking that down. And it also helps the client to understand his investment for future, because he can look at where he can put where does he get his biggest bang for buck in investing in new pipes and infrastructure. Another way that we can look at the intelligent management of assets is going back, in this case, with hypermodeling. I'm sure we're all familiar with this sort of situation. In my experience, it's also raining as well when you've got a drawing like that. But you can go out to site with a smartphone or an iPad or a tablet of some sort, and you can start to interrogate the building. So we have some icons in there. You click on that, you pull out the 2D record information. You maybe take a cross-section. You pull up the 3D model. You look at some of that design content. You overlay a 2D detail that comes from a logbook, perhaps. You might overlay a manufacturer's set of information. But it's just a more efficient way of going out on site. Again, you're taking all this information that exists on your servers and your systems that someone's created for you. But because it's been created in a smart way, and people, when they created it, were thinking, okay, how's this going to be used further down the line? You can more easily plug that in to a system like this to use for operations. So it's a very efficient way of working. And also then just looking at utilities. In the same kind of way, again, in Europe particularly, local authorities are putting a lot of effort into smart infrastructure for underground services, because when you dig up roads, that causes big disruption. It becomes very expensive. And it's just a very simple example, but it just shows how you can interact with the data. Now, it's still not accurate enough to give you the confidence that if my iPad tells me there's a high voltage cable here, and it's a dead cable, I can cut it. I still wouldn't have the confidence to go out and do that, because the technology isn't there yet. It's getting close, but it's not quite there. But you can see we overlay the geotechnical information. This is some ground penetrating radar. And what you can do is you can start to collate some of this information, so you overlay one on the other, so you start to become more and more accurate. And this information can be tagged with details about age and who installed it and warranty periods and all the other good stuff. So it's just trying to use that infrastructure information intelligently to give real benefit to a client. So going back to the title on the main page, that's kind of the, I suppose, the encapsulation of how you do that. So how do you link BIM to all these different things? It's really through asset lifecycle information management, which encapsulates the information modeling, the integrated projects, and then delivering intelligent infrastructure. But it's really important, I must stress, there's so much hype around BIM at the moment. There really is. And you can't open a trade journal, in fact, come to an event like this, and we see all the kind of leading edge stuff, the nice, sexy, glamorous stuff. And time again, I find people that have invested money in doing this stuff only to find they can't press a button and magically have all this stuff happen. They have to put time and effort into making it work. Now, eventually they get to a point on the right-hand side when they start getting value. But it's less than advertised, it's less than they bought into. So the trick is to really use that red dotted line. So plan what it is you do. Think about why you're doing it as a business. And the business drivers for a design consultancy will be different from a subcontractor to a fabricator to a supplier. The key thing is to understand what those drivers are. And by doing that, you do really get a good return on investment. And we've seen some case studies this morning. Some big percentages, everything from 5, 10%, right up to 30% savings are possible when you do this stuff properly. And it's really important to develop a plan and manage the risk. So every business is different. Every business needs a different plan. But it's really important to understand what your plan for BIM is, what value it gives you. And it could be in creating the content, in the intelligent modeling. It could be in the integrated project approach if you're a contractor on site, or it could, if you're an owner-operator, being the final life cycle stage. But develop that plan and really manage the risk. And don't end up being the guy holding the risk at the end of the job. Thank you.